In the heart of ancient deserts, beneath layers of time and sand, lie remnants of a technology so advanced that modern science still struggles to explain it. Imagine holding a tool, a mechanism, or a structure that predates the known limits of human engineering. A relic whose precision challenges our understanding of ancient cognition. The idea that civilizations thousands of years ago could conceive, design, and construct objects or systems that rival our modern achievements forces us to confront the nature of human ingenuity, the limits of knowledge, and the invisible threads connecting past and present. This is not merely a story of lost civilizations or forgotten techniques. It is a window into the neural architecture of human creativity, the collective intelligence of societies under stress, and the philosophical implications of what we define as possible. When we look at these artifacts, whether it is the intricate gears of the Antikythera mechanism, the precisely cut stones of Puma Punku, or the astonishing alignment of megaliths at Nabda Playa, we are confronted with a paradox. Our contemporary science can measure, describe, and analyze these structures, yet their origin and method remain shrouded in mystery, suggesting that human cognition, even in the distant past, was operating in ways that are not entirely captured by linear historical narratives. Consider the Antikythera mechanism, often dubbed the first analog computer. Discovered in a Roman shipwreck off the coast of Greece and dated to approximately 100 BCE, this bronze device contains over 30 interlocking gears, capable of predicting solar and lunar eclipses, planetary positions, and even Olympic cycles with astonishing precision. To understand the sheer sophistication of this object, imagine your own brain as a system of networks, where neurons communicate through electrochemical signals to generate prediction, imagination, and memory. The creators of the Antikythera mechanism were, in a sense, externalizing a portion of their neural network, constructing a mechanical representation of the cosmos that extended their cognitive capacity. Just as a neuron fires to anticipate a stimulus, the gears of the mechanism rotate to anticipate celestial events, bridging the gap between perception, memory, and action. This is an ancient metaphor for how societies manage uncertainty and complexity. The mechanism is both a scientific tool and a cognitive prosthetic, illustrating that technological innovation is often an externalization of mental computation, a physical manifestation of an internalized understanding of patterns. Yet, the Antikythera mechanism is not an isolated example. Across continents, from the high plains of South America to the Nile Valley, we encounter evidence of technological feats that defy conventional explanations. The precision-cut stones at Puma Punku in Bolivia weigh multiple tons, some exceeding 100 metric tons. Yet they are fitted together with tolerances so exact that even modern laser technology struggles to replicate them. The surfaces are so perfectly planar and the angles so precise that it suggests a mastery of tools and techniques far beyond what is assumed for pre-Incan civilization. From a psychological perspective, one might consider this the manifestation of a collective attentional focus, a distributed cognition operating at the level of the society. When a community faces environmental pressures, resource scarcity, or existential uncertainty, cognitive resources are not merely individual but shared, forming a networked intelligence that can produce outcomes far exceeding the sum of individual capabilities. Each stone, each cut, each placement is not merely a task. It is a signal of coordinated problem-solving, a reflection of a society's adaptive strategy encoded into matter itself. This interplay between collective cognition and technological expression invites a deeper reflection on the nature of human perception. Neuroscientific research shows that the brain constructs models of the world, predicting outcomes and optimizing behavior in real time. Ancient engineers, artisans, and astronomers were doing something remarkably similar, but with tools, materials, and social structures as their medium. When we observe a perfectly aligned megalith, we are witnessing the externalized predictive model of an entire community. The alignment is not accidental. It is a deliberate mapping of celestial cycles onto the terrestrial landscape, a bridge between abstract knowledge and tangible action. Philosophically, this challenges the assumption that technological sophistication is inherently modern. Perhaps what we perceive as a limitation of ancient peoples is, in fact, a limitation of our understanding, a cognitive blind spot imposed by the linear narratives of progress. In other words, the past is not simply primitive. It is differently sophisticated, operating along axes that our contemporary frameworks have not yet fully mapped. The human capacity for abstraction, pattern recognition, and symbolic thinking is central to this phenomenon. In a society, stressors such as environmental unpredictability, migration pressures, or social instability catalyze innovation. Neurologically, stress triggers adaptive plasticity, enhancing problem-solving and memory consolidation. Historically, we see this pattern repeated: the building of megalithic structures, the development of astronomical calendars, and the creation of complex devices all emerge in contexts where survival and social cohesion are at stake. These are not arbitrary feats of ingenuity, but evolutionary strategies encoded in cultural practice. The architecture of Puma Punku, or the gears of the Antikythera mechanism, is, in this sense, a record of adaptive intelligence, a neural echo amplified across generations, crystallized in stone and metal. Every precise cut, every calculated alignment, every functional design element is a testament to how societies externalize cognitive processes to manage uncertainty, predict outcomes, and stabilize collective behavior. But the story does not end with precision alone. Consider the Nabta Playa complex in Egypt, dating back to 4500 BCE, which features stone circles and alignments corresponding to solstices and stellar positions. These early astronomers were effectively translating temporal patterns into spatial representations, transforming ephemeral knowledge into durable artifacts. Cognitive scientists refer to this as cognitive scaffolding, where external tools augment memory and reasoning capacity. By constructing physical representations of time and celestial cycles, these ancient peoples extended their cognitive reach beyond the limits of the brain, creating a shared, persistent model that guided agricultural, ceremonial, and social practices. This is a profound insight into human psychology. Knowledge is not only stored internally, but can be encoded into the environment, creating a feedback loop between cognition, culture, and material reality. Modern science marvels at these feats, but perhaps the deeper lesson is philosophical. Intelligence is not a singular, isolated phenomenon, but an emergent property of networks, both neural and social, material and conceptual. As we examine these technologies through a contemporary lens, it is tempting to project our own scientific paradigms backward, assuming that sophistication implies complexity as we understand it. Yet there is an elegance in the simplicity and intuitiveness of ancient solutions. The Antikythera mechanism's gears do not require electricity. The Puma Punku stones do not rely on modern machinery. Nabta Playa's alignments require no computers. They demonstrate that intelligence operates independently of specific tools, emerging wherever perception, memory, and social coordination converge. This reframes our understanding of history. Progress is not linear, and technology is not solely additive. Sometimes knowledge is encoded, lost, or transformed in ways that challenge conventional chronologies, creating what we might call cognitive anomalies, instances where the output of a society's neural and social networks surpasses the expected technological horizon. These anomalies invite us to reconsider our assumptions, to question what it means to be advanced, and to explore the untapped potential within both individual and collective minds. There is also a psychological twist embedded in these discoveries. We often measure historical competence against our own standards, assuming that ancient peoples were limited by the absence of modern tools. Yet these artifacts suggest that cognitive and social constraints were not weaknesses but adaptive strategies. The meticulous stonework of Puma Punku, the gearing of the Antikythera mechanism, and the celestial alignments at Nabta Playa are products of intense focus, distributed problem-solving, and environmental attunement. What appears as a gap in knowledge from our perspective may have been a feature, not a flaw, of their cognitive ecosystem. In other words, societies that seem technologically primitive might have been optimally adapted to their context, externalizing their intelligence in ways that enhance survival, cohesion, and cultural continuity. The twist is profound. What we perceive as limitation is often a sophisticated solution, a hidden architecture of adaptation encoded in the material and symbolic world. From a neurophilosophical perspective, these ancient technologies invite reflection on the architecture of human thought itself. If cognition is a dynamic interplay of neurons, synapses, and networks, then culture and technology can be seen as an extension of this neural substrate into the external world. Each artifact, each structural feat, each alignment is a projection of internal processes into shared reality, a tangible map of abstract reasoning. The precision, foresight, And coordination embedded in these objects mirror the principles of predictive coding in the brain, where the mind continuously models and anticipates sensory input. Ancient engineers were, perhaps unknowingly, engaging in an externalized form of this computation, transforming material into memory, structure into strategy, and observation into prediction. By studying these technologies, we gain insight not only into historical practices, but also into the fundamental nature of intelligence. It is both embodied and extended, private and collective, ephemeral and enduring. As we continue to uncover, analyze, and interpret these ancient artifacts, a philosophical question emerges. If such technological sophistication existed thousands of years ago, what does it tell us about the trajectory of human knowledge? The assumption that modern science represents the pinnacle of understanding may overlook the cyclical and context-dependent nature of innovation. Ancient societies faced unique challenges that demanded ingenuity and precision, producing outputs that remain enigmatic precisely because they are optimized for contexts very different from our own. This encouraged humility in scientific inquiry. The past is not merely a backdrop for our achievements, but a repository of strategies, insights, and cognitive architectures that can inform contemporary thought. In essence, the technologies we study are not relics of curiosity. They are mirrors reflecting the latent capacities of human cognition when nurtured by necessity, focus, and communal effort. Finally, we confront the ultimate lesson embedded in these ancient technologies. Intelligence, creativity, and adaptation are emergent phenomena that arise from the interaction between mind, material, and society. The gears of the Antikythera mechanism, the stones of Puma Punku, and the celestial alignments at Nabta Playa are not isolated curiosities. They are the physical traces of a sophisticated interplay between perception, planning, and collective action. They remind us that history is not a linear march toward modernity, but a complex web of solutions, insights, and experiments, many of which surpass our present understanding. The philosophical implication is profound. By studying these artifacts, we do not merely reconstruct the past. We expand our conception of what human beings are capable of, revealing that the potential for extraordinary insight is not confined to the present, but distributed across time, encoded in both material and mind. The act of observation, analysis, and reflection on these ancient technologies is itself a continuation of this cognitive chain, linking us to minds long vanished but whose echoes persist in the stone, metal, and celestial alignments they left behind. If this exploration of ancient technology has expanded your sense of possibility and made you reconsider what it means to be human, I encourage you to share your thoughts in the comments, to like this video if it inspired you, and to subscribe to Pastlens for more journeys into the hidden, the enigmatic, and the profoundly human stories that history and science reveal.